Hello there, and welcome to Hacktivity Explained, the series where I go over some bugs found by other bug bounty hunters in the hopes that we might learn something from them. Keeping in the theme of JavaScript bugs, like with the video I made recently, we're going to be looking at some vulnerabilities found in JavaScript. The first one is a vulnerability where someone found some exposed credentials in JavaScript, so specifically AWS credentials. And the second vulnerability is going to be looking at post messages and a Google vulnerability where post messages were used to achieve cross-site scripting. So stay tuned. Right, on to our first report, and this is the one with the exposed API key. Basically, what happened is that the bug bounty hunter was able to find a developer-only domain. In this case, it was some kind of like this example.com. They don't have tag in here, but it's just some kind of developer domain. And usually what happens is that when you go on this domain, it redirects you to some kind of single sign-on. In this case, it was just Microsoft login page. Since the single sign-on is usually pretty secure, it's usually either Microsoft, it's often also Okta, and these are very secure services, so hacking doesn't really make any sense. What we do want to hack is to try and hack the implementation of this service, which is always a good idea. So one thing that you should always do is try and basically force this endpoint. So try and find endpoints in this case. What you can often find is a lot of the time some kind of like architecture. So in this case, you can find like you see SOAP, like API stuff like that. You can sometimes find like Spring loaders on these kind of applications. And one time I remember that one hunter found like a XML file, which was publicly open. You could access it without credentials, and it just like stored the recent login attempts with the password. So that was pretty interesting. I think they got a pretty good bounty for that. Well, you can find stuff like that on these developer websites, and it's worth looking for them. The second thing that's worth looking for is JavaScript. So sometimes what happens before redirecting, the website will include the JavaScript in the actual web page. You won't be able to see it if you're like a normal user because you'll go in and get redirected instantly. However, if you stop the redirect or you're looking at it in a HTTP proxy, you will see like scripts that are like loaded inside, and that means that we can have a look at them and then get the endpoints of the page, because these scripts are being used in the main application, but they're being loaded in like by mistake, so they're going to expose things, right? And often developers think that because it's a developer website, we don't have to like secure it or anything like that. So finding like these kind of weak authentication vulnerabilities on these platforms is quite easy, especially when you find kind of, well, I don't want to say easy, but once you actually have access to them, it's a lot easier to find security vulnerability just because developers assume it's safe, right? And in this case, the JavaScript was included, so the bug bounty hunter found the JavaScript, and then they just searched for some common patterns like API keys, stuff like that, and they found basically Amazon AWS API keys. In this case, it's a service called Cognito, and Cognito is something that allows you to create like a login page. It kind of manages like sign in, sign ups, and stuff like that. So it's pretty bad if you manage to find credentials for that because you're able to like register and stuff like that. And yeah, they were able to register in the Cognito service, and they were able to try and get like the AWS API key, and they managed to do that. And yeah, that's basically it. They managed to get the. Oh yeah, they were saying that the first thing they found didn't have as much permissions, and then what they did was, this is actually something very good, is that they looked for the vulnerability but on the different web pages. Right, if you find one vulnerability, it's likely that the developers made the same mistake a couple of times, so it's worth checking for other subdomains if there's a mistake there as well. And in this case, they did that, and they found another vulnerability in the same program, which is very good. And yeah, if you do manage to find one of these, then it's good to look for patterns. Developers make mistakes in patterns. It's usually the same person who makes a lot of this, by the way. Like these teams, unless it's like a super big company like Google or something, a lot of the time it's actually the same person who implements it. A lot of the times they'll be making the same mistakes over and over again. So if you catch them once, you can catch them a few times, and you can turn like a $2,000 bounty into like a $10,000 payout by basically just finding the same bug 5 times and then reporting it each time. Sometimes they'll be marked as duplicate, but if it's like the same bug type but on like a different occurrence, then it should be marked as a different bug, right? And what's super smart as well, this is actually what I really like about this bug hunter's approach here, is that they made an actual JavaScript script here, like a bit of code to detect this vulnerability whenever they were looking at a developer website, and they had it run automatically, which is also super good. If you find like a common misconfiguration that you don't think has been exploited yet, then it's really good to make a script and then just go over other subdomains to try and find the same thing, which is really good. So this script here is what they made, and this actually did get them a few more vulnerabilities, so it was probably worth it, right? I mean, can see that if you find one and then you can exploit it. That's why misconfigurations are kind of nice to hunt for. If you can hunt for misconfigurations, if you find it on one platform, a lot of the times it'll be present on a lot of platforms. I think I was listening to like a podcast, and there was like this bug bounty hunter. He's a fella from Dublin as well, actually, and he hunts specifically for misconfigurations. And whenever he finds one, he makes a script that finds it in like all the other programs he's hacking on, and then he gets like a huge payout for it. So that's a good approach to trying to maximize your payout for a vulnerability. I think also the bug bounty hunter mentioned a couple of tools. I just have them here. It's get.js one, which just basically downloads all the JavaScript files for you from the URL page. Probably good if you want to just quickly check it. And then source mapper basically creates a source map. So source map is like what you can kind of use to unminify JavaScript, and this kind of just makes it more readable. So some people use this to basically help them read JavaScript. I think most browsers do this by default though. If you go like debugger, and if you go to say, I don't know, where's like this JS file, right? The source map usually gets loaded by default. In this case, it's just sometimes it's not there. But you can also just like pretty print it like this, and it's a bit easier to read now. So I think most browsers do this by default. The one thing I do recommend though is when you have a HTTP proxy, then you should be able to actually check if the scripts are loaded in there before you get redirected. Because if you go onto these websites in like a normal browser, you get redirected and you won't even see that the thing got loaded. So it's worth checking that as well. And yeah, that's kind of it for this vulnerability. I have no idea how much the hacker got paid for this. This is Mohammed Ibrahim. Very good write-up, actually easy to follow. And yeah, something we can learn from as well. For this next vulnerability, I actually made a lab. So you can go onto my domain here, this pm/main.html, and you can try find it yourself. A reminder is that this is a post message vulnerability, and you want to try and pop an alert box here. So you want to pop like the alert one thing. And if you can do that, then you've solved the challenge. So you can go off and do that, and now I'll explain the vulnerability. This bug was in Google, so the Google Bug Bounty program, specifically in Gmail, as you can see here. The thing about Google and these big platforms is that they have huge amounts of infrastructure, right? There's some like you see Google Hangouts, you have Google Calendar, Google Tasks, Mail, and Workspace is also a big thing. Because of this infrastructure, a lot of scripts and like code has already been created in other platforms. What these companies tend to do is instead of making them again for something like email, where they want to include some other like services, what they'll do is they'll actually iframe the other service and then include it in another service, right? So in Gmail, you can see that Hangouts.google is here. You can see like calendar and stuff like that. And these are all taken from their other domains, which they've already created. So they're just kind of reusing that infrastructure. And you'll see this a lot in like Google, you'll see this a lot in Meta. These huge like multinational companies, especially Microsoft actually is a big one. With Office, you'll have a lot of wireframes there. And that makes it pretty good for attacking client-side vulnerabilities, just because there's a lot of iframes going on, there's a lot of client-side rendering. That's very good for those kind of vulnerabilities. And what the attacker here talks about, sorry, Hunter, is this kind of post message tracker tool they're using. I use another one. It's called post message tracker. They're using something called post message logger. It doesn't really matter what you use. The point is that you need to be able to go into the inspector tab and see these things, right? So you want to be able to see the post messages. That's really important. You want to see from where is the post message getting sent to and what data is being included in it. That's the two most important things, right? That's what you want to be able to see. Without that, it's actually very hard to hack post messages. And I do recommend you get either this thing that they're using, so post message logger, this kind of extension, or the thing I use, so post message tracker. And yeah, that's what they give you here. This is what his one looks like. Maybe I'll zoom in a little bit. This is what his one looks like. It just tells you like message received, the origin, and the data. Maybe his one is actually a bit better than mine now looking at it, because this actually tells you the origin and stuff like that. However, it doesn't really matter what you use again. The thing that the attacker noticed here is that inside the data, you see, there's a little URL here, right? So there's a URL, which is interesting. That's already a good start. We have a URL, and that URL is actually being loaded in by our browser. It's the exact same URL, right? What this tells us is that potentially this data is being passed into some kind of ref attribute or some kind of link or some kind of iframe. And the attacker actually confirmed this with very confusing JavaScript. I have to say that this took a little bit of time to read, especially because it's all minified. But from what I can get from this is that he found that the Google script was taking this URL from the post message, and this is the main domain, so gmail.google. He was taking the script was taking the URL from this, and it was putting it straight into the source of the iframe. And there didn't seem to be any validation here. So here you have this function here, which I assume is the function that creates the iframe, and it uses the append child function. So append child, what it does is it takes a tag and it sticks it into the inner HTML of another tag. It's called append child, pretty self-explanatory. So I assume here you can see the source hangouts.google.com. So I imagine this was basically where it was getting injected, and it was coming from a post message from another iframe. So another iframe was telling it to basically change the source. You can see that's where the function is being called, and this is where the iframe is sending the post message. And what you can do with that is a very old trick actually. It's the JavaScript URL parameter. Coming back again, a lot of developers forget about this. So the JavaScript URL parameter allows us to basically execute JavaScript on a URL. I still don't know why this even exists. I've actually never seen this used in like a production environment. I don't know why they would even have this anymore. But it's there, so if a lot of developers forget about it, and it's a good way to get cross-site scripting. Actually, one of the main ways I've seen recently. So you can use the JavaScript parameter, and basically imagine what they exploited it was that they iframed the main Google page. So they iframed it, made Gmail here, and then they sent a post message to it telling it to open this JavaScript URL, so you could get cross-site scripting on Gmail from a victim who clicks on your own website. That's what I imagine the exploitation here was. Of course, content security policy comes in. So content security policy is something that prevents scripts from being executed if they don't match like specific rules. So in this case, if they don't have a nonce, like a specific ID passed down by the server, or if they're not from a specific domain that it's being allowed by the website. And in this case, Google has a pretty strict one, so it's not allowed, but it wasn't enforced by Edge. Yeah, it is now though. That's a bit sad. Yeah, it is now. Content security policy. It's a bit of an annoying one to be honest, and yeah, it's hard to get around because modern browsers will always enforce it now. Thing is, like Google will still pay you if you don't pass the content security policy, which is nice. You'll get a little bit less bounty, so I think the attacker got paid $5,000 for this. I've seen cross-site scripting vulnerabilities in Google that get paid around $2,000 without having bypassed the content security policy. So I think you lose out on like $3,000, which I guess is a lot, but it's hard to bypass this, especially on like something like Google. Although there's definitely ways to do it. And another issue was that when the post message was getting sent, let's go back here. There's like this 6-character thing here, which identifies where the post message is coming from. And this just basically the top level domain verifies that this ID matches the ID that it gave to an iframe. So an attacker has no way of knowing this because we can't go into like we can't see what Gmail has actually done there. We can't see what ID has given the domain, or sorry, the iframe. So therefore, we can't really predict what this is going to be. That's another thing, and the attacker, I don't think, found a way to bypass this. Apparently, was using maths.random, so probably was bypassable sometimes, but it wasn't in this case. Yeah, so they weren't able to bypass that, but they still reported it, and because it's Google, they still got paid like $5,000, which is pretty insane to be honest. And yeah, they got a decent payout. This program was a bit harder to read, to be honest. This write-up was a bit difficult, so hopefully I explained it to you in a way that's understandable to you. And yeah, the lab here, it follows the same way where there's an iframe here, that when it's loaded, it tells the top level domain to load a URL. And in this case, if you iframe the top level domain and send in a JavaScript URL, you can achieve XSS or cross-site scripting on the top level domain. So the same vulnerability applies here as well. Also, no pressure, but if you watch this far, I think you'll enjoy some of the practical labs that I have released on this channel. You can find them in the description below or just on my channel icon. They're hands-on practical labs that you can try yourself just in the browser, the same ones that I basically gave on my video, just they're a little bit more thought out and based on some of the vulnerabilities that I found that have made me a decent bit of money in the future. So there's currently 12 of them, and you can visit the link in the description, but again, no pressure. I hope this video showed you some of the cool things you can find with JavaScript, and I hope this actually showed you as well, like with the first vulnerability, that it's not always just client-side vulnerabilities, although often it is obviously because it's client-side JavaScript. However, you can also look for server-side vulnerabilities like leaked APIs, or just find endpoints in general, and obviously broken access control, something like the developer domains, is something that we can also look for. And yeah, if you have any suggestions on content I should make in the future, then please leave it in the comments below. I always try my best to make the videos that are suggested to me as best as I can, obviously. And if you suggest it in the comments, I'll probably make it soon if it's something that I feel is actually beneficial to the channel. And yeah, that's it for me. Thanks for watching and happy hunting.